Hello, this is a video to talk about oncogenes and protooncogene. It was developed by students of the Escuela Nacional Preparatoria No. 6 Antonio Caso, Group 610 for the teacher of English Javier Bautista Ramirez. Most of us wonder, what is a protooncogene? It's a normal gene that regulates some normal growth functions in a cell, but this protooncogene may suffer from mutation or translocation to other chromosomes, wherein a function is affected. Another frequent question is, what is an oncogene? It's a gene that causes abnormal functioning or resting cell growth that leads to the formation of tumor. It's a consequence of mutation or translocation of a protein. But what are they for? These encode proteins that help regulate cell growth and differentiation. They are also involved in signal traduction and execution of metagenic signals, usually through their protein products. Now, we identify protooncogene. This can become a tumor-inducing agent, which will become an oncogene, and this in turn is a gene that helps turn normal cells into cancer cells. But how it can transform a protooncogene into an oncogene? We can find different mechanisms, such as translocation is when part of a chromosome is linked to another. The result is a hybrid chromosome, detectable in karyotype.
Another way would be by amplification, when eukaryotic cells are formed by a diploid genome. In other words, they have two copies of each gene. In certain circumstances, one of the copies can multiply more times, increasing its rate of expression, leading to gene amplification. To counter this also there exist suppressor genes, which are genes encoding proteins capable of inhibiting cell proliferation by blocking the activity of oncogenes and oncogenes products. Suppressor genes inhibit cell growth under normal conditions. When a mutation occurs in these genes, express or result in non-functional proteins, favoring the emergence of the process of carcinogenesis, the absence of control of cell proliferation. For these suppressor genes acquire their tumorigenesis, they need to undergo independent mutation in both alleles, so that completely lose their functional capacity. Consequently, cell growth is irregular, producing an uncontrolled proliferation, which can lead to tumor formation. Alteration is manifested by RECISE. It can also be inherited, this alteration in the germline, which will explain the hereditary nature of certain tumors, whose frequency rises in the same family. In this case, one of the alleles is inherited altered, so that a mutation is needed in the other allele, so that in this case manifested itself. Cancer is therefore the result of an uncontrolled proliferation of cells with an abnormal genetic material. Aberrant cells that escape mechanisms that have the body to prevent disease are not eliminated and perpetuate anomalies in their offspring. Which of the following images shows an example of the mutation that we mentioned? What is important to study gene mutations?
Created using Powtoon.